In this video, we will discuss about binomial expansion. Now, when you have a plus b raised to n, okay, and this n can be any natural number. So this n value can be 1, 2, 3, up to any value, okay, basically a natural number. Then how do you expand, okay, is what we're going to discuss. But before we get to the binomial expansion, okay, that is going to be our third method. The name of the topic, the binomial expansion, is going to be our third method. The first method you already know and you're familiar with this. So let me start with the first method, and method one is by multiplication. By multiplication. Now, for what I mean by this is suppose if you have a plus b the whole square, okay, how do you find this expansion? Say n is 2 right now, right? Now for this expansion, a plus b the whole square is nothing but a plus b multiplied with a plus b. Okay, how do we multiply two brackets? Okay, the first a multiplied with this bracket, a plus b, then plus b multiplied with this bracket again, a plus b. Now if you multiply, I'm sure you know this answer already, but I'm just like solving this. A into a is going to be a square, plus a into b is going to be ab, plus b into a is also ab, and b into b is going to be b square. And then you'll always add the two. AB and AB is going to be 2AB, and the answer is a square plus 2AB plus b square. And this is a standard formula in algebra that if you have a plus b the whole square, then you can write it as a square plus 2ab plus b square. Now this was the first method where I did multiplication. I just multiplied two terms. Okay, so this was the first one. Okay, supposing if I want to find out a plus b the whole cube, okay, can I find that? Yes, it is going to be a plus b times a plus b times a plus b. I have to multiply these three things. Okay, there is going to be a lot of effort that we have to put and do a lot of multiplication, and then we will get the answer. So, and you perhaps already know the answer, but then it is going to be some work. Okay, you have to multiply all these brackets. Okay, but still you can achieve a plus b the whole cube by multiplying. Now I'm sure you clearly understand. Supposing you want to find out a plus b raised to say 7. For a plus b raised to 7, there are these 7 brackets I have to multiply. Okay, do you understand? It is going to be a lot complicated, very, very complicated, okay, to find out the expansion of this. So if you have to expand a plus b raised to 7, so much of multiplication has to be done, right? So the method one by multiplication is the straightforward method, but I'm sure you agree that this method is not very efficient or not very good when you have higher powers. Okay, now the best method of course is binomial expansion. Okay, we'll come to that, but before we go to the third, the binomial expand method, there is one more method. I don't know if you've heard of this. That method is called as the Pascal Triangle. So we're going to go to that now. So the method 2 is it is called as Pascal's Triangle. Okay, and it is quite interesting method. You will see that tell me, if you have a plus b the power is 1, okay, then it is going to be just a plus b. Okay, so if I want a plus b the whole square, I can simply multiply it 2 times, a plus b times a plus b, and we know the answer already, a square plus 2ab plus b square. Okay, this much you should ideally know. Okay, so if we know so much, see that for this, can we write down 1 and 1? Do you see the coefficient of a is 1 here and coefficient of b is also 1 for power 1? Okay, now when you want to find out the coefficient of a plus b the whole square, okay, by Pascal triangle method, you simply have to drag this one here. Okay, then you have to add this one and this one, so it's 1 plus 1 is 2, and just drag this one onto the right hand side. Do you see 1 2 1? Do you see 1 2 1? So clearly with this method you can generate coefficients. So tell me that if I have to drag 1 here, okay, this 1 and this 2 is going to give me 3, this 2 and this 1 will give me 3, and when you drag the 1 here, Okay, so now these must be the coefficient for the next expansion. So let us write down the next expansion, okay, using those coefficients. It is going to be a plus b the whole cube, okay, and the coefficient for that are going to be, so let me keep the colors as it is. It is 1, 3, 3, and 1. Okay, so I don't know if you already know this expansion. This is also a standard formula. So whenever you get a plus b the whole cube, the expansion is a cube plus 3a square b plus 3ab square plus b cube. And I am sure you understand that we can just keep on going like this. Okay, we can keep on extending like this. So how will that be? So let us do one more. Say if I extend one here, and then this is 1 and 3, it's going to give me 4. Then this is 3 and 3, you have to add these two, so you get 6. Then you add 3 and 1, which is again 4, and then extend 1 here. Do you see a triangle forming here, sort of? And this triangle here is called as a Pascal's triangle. And from this, you can write down a plus b the whole raised to 4. So if I want to write a plus b the whole raised to 4, okay, I'm sure now by now you've seen some pattern here. When you have a plus b the whole cube, you have a cube here and b cube here. So when you have a plus b raised to 4, it will be a raised to 4, the first term, and the last term is going to be b raised to 4. Okay. Do you also see that when you have a cube as the first term, the next term is a square? Do you see the power reduces from 3 to 2? Then it goes from 2 to 1. Do you see a raised to 1 here? And then from 1 to 0, the a just disappears. Okay. So we have to keep on reducing the power of a. So this will be a raised to 4. Then it is going to be a cube. Then it will be a square. Then it will be a raised to 1. And then it is 0. Okay, coefficients I can write from here 1, 4, 6, 4, 1. So where are the coefficients? Okay, the coefficients are 1, 4, 6, 4, 1. Do you see? And then what happens to b? Tell me. Of course, we'll write down plus sign in between. So this is plus, then this is plus. Okay. Now what happens to b? Do you see a cube? As a reduces, b increases. So you will have a cube b, then you'll have a square b square, then you have a raised to 1 b cube, and finally b raised to 4. So basically you have to understand that power of a reduces, okay, and power of b keeps on increasing. Okay, so there is a trend for sure. But once again, now if I have to find out, say, a plus b raised to 15, supposing I want to find out expansion of a plus b raised to 15, do you understand the Pascal triangle is also going to be a tough way of solving, because I cannot start in between, right? I cannot directly get the values here. I have to start from 1, 1, okay, and keep on stretching, keep on adding, and I'll get this answer. But then there is a lot of writing, even to find a plus b raised to 15. So I want you to understand, definitely the first method where you multiply 15 times is horrible. But even Pascal triangle is not going to work so well. Okay, so when you have a bigger power, okay, you really need something smarter, and that's the method which is called as a binomial expansion. So now this is third method, is called as binomial expansion, and there is a formula for binomial expansion. But instead of writing general formula, I will tell you how this works. Supposing if you want to find out a plus b raised to 7, okay, if you want the expansion of a plus b raised to 7, just bear with me, I will tell you how this works. The formula is like this. It is, first term will be 7c0. I'll explain meaning of this in a minute. Then you write first a term raised to the highest power is 7, and b raised to 0. Just remember the first term and everything else will fall in place. So what you will do, first you'll write 7c0. I'll explain this. Then a raised to 7 and b raised to 0 is going to be the first term. Okay. Now, once you get the first term, I'm sure you can imagine the next term. The next term will be, after 7c0, the next term is 7c1. Then you have to reduce power of a. Do you remember? So if you have a raised to 7, you reduce the power, it will become a raised to 6. And now b raised to 0. For b, you will increase the power. So the b raised to 0 will become b raised to 1. Okay, you have to keep on going like this. The next term will be 7c2. Okay, after 7c1 you write 7c2. Keep on reducing the power of a, so a raised to 6 will become a raised to 5, and b raised to 1 will become b square. Okay, keep on doing that. So plus dot dot dot, and then tell me the last term. Okay, you will keep on doing 7c0, 7c1, 7c2, 7c3, 7c4, 7c5, 7c6. The last term will be 7c7. A ka power you will keep on reducing, a raised to 7, a raised to 6, a raised to 5, a raised to 4, a raised to 3, a raised to 2, a raised to 1, a raised to 0. The last term will have a raised to 0, and b power is keep on increasing and it will become b raised to 7. Okay, so I hope you understood how the binomial expansion formula is written. Okay, now I have to explain to you how this 7c0 and 7c1 is going to be. But before that, okay, let's do that first. So if you want 7c0, the formula for that is called as NCR, and the formula for NCR is n factorial r factorial n minus r factorial. Lot of new terms, right? We will be discussing all this in detail later on, but then just remember this formula is called as a combination formula. There is a chapter called as permutations and combinations where we'll do all these things in detail. But as of now, can you remember the formula? The formula is NCR is equal to n factorial divided by r factorial n minus r factorial. Now I'll tell you what is factorial. Supposing if you want, say, 4 factorial, okay? 4 factorial is simply means 4 into 3 into 2 into 1. Don't do into 0, okay? Otherwise, the whole thing will become 0. So 4 factorial, when you say, you just have to start from 4, keep on reducing this number and just keep on multiplying. So tell me about 3 factorial. 3 factorial will be 3 into 2 into 1. I hope you can imagine. 2 factorial will be 2 into 1. Okay. Now, what is 1 factorial? 1 factorial is just 1. 1, right? What is 0 factorial? Well, 0 factorial is also 1. Okay. And make a good note of this point, that whenever you have 0 factorial, the value of 0 factorial is just 1. Okay. And there are a few more things that I want you to understand. After 0 factorial, what if I say minus 2 factorial? Okay. Minus 2 factorial is invalid. So you basically cannot find factorials of the negative number. Factorial is not valid for the negative number. Okay. What is the factorial for 1.5? Okay. So you even for 1.5 for fractions, it is invalid. So please understand, the factorials are to be used only for the whole numbers from 0 onwards. For negative numbers, you can't. For fractions, you cannot. Okay, you can only use for the whole numbers. Okay, from 0, 1, 2, 3, 4 onwards. Right? That's the idea of factorial. Now, after knowing all this, okay, can you tell me the value of 7c0? 7c0. Okay, all you have to do is use this formula, okay, and find out the value of 7c0. Okay, you have to understand that now n is 7 and r is 0. 7c0 ncr. N is 7 and r is 0. So how will this formula work? This will become 7 factorial. Do you see? N is 7 and r is 0, right? So it is 0 factorial. This is 7 minus 0 factorial. Okay, 7 factorial. Okay, I'll just leave 7 factorial as it is. This is 7 factorial. 0 factorial, we all know it is 1. Can you see that here? The value of 0 factorial is 1. And 7 minus 0 factorial is 7 factorial. Do you see numerator and denominator both has 7 factorial will cancel out and you will get answer as 1. So now this term will have value 1. Now you can keep on doing this. You can find out 7c1. Okay, 7c1 will be 7 factorial. Okay, now you have n as 7 and r as 1. Then you will have 1 factorial. 7 minus 1, that is going to be 6 factorial. Okay, so how will you write this? 7 factorial would be 7 into 6 into 5 into 4 into 3 into 2 into 1. We'll multiply all the numbers here. 1 factorial value is just 1, and 6 factorial will be 6 into 5 into 4 into 3 into 2 into 1. And do you see again, this will cancel out with this, and only 7 by 1, that means it will be 7. So we have value of 7C1. Okay, 7C1 is 7. So now with all these values, can we write down the final expression of AB raised to 7? So let me write down the final answer for this. If you want to find out A plus B raised to 7, okay, this will become 7C, the first term. Okay, I'm writing down this term. 7C0 is 1. A raised to 7, B raised to 0 is also 1. So you'll have only A raised to 7, the first term, plus, okay. Then 7C1, we have just solved 7C1. The value is 7, right? This value is 7. 7, A raised to 6, B raised to 1, plus. Now we can also find 7C2. Chalo, let's do one more. 7C2. Okay. For 7C2, you will use combination formula, which is NCR. N right now, if you compare this with NCR, N right now is 7 and R is 2. So you'll get this as 7 factorial. This is R factorial is 2 factorial. And 7 minus 2 is going to be 5 factorial. So let us solve this. Do you know 2 factorial is 2 into 1? Okay. Now for 7 factorial, you can write it as 7 into 6 into 5 into 3. But instead of writing 5 to 3, 5, 4, 3, 2, 1, can I just keep 5 factorial as it is? See if you understand this step. Instead of writing 5 into 4 into 3 into 2 into 1, I'm just keeping 5 factorial as it is. Why is that? Because denominator also has 5 factorial. So these two will cancel out, no? Okay. And now 2 3s are 6 and 7 3s are 21. So the value of 7C2 is 21, and that value I can write here. This is 21. Okay. So the next term has got 7C2, which is 21. Then this is A raised to 5. Do you know that power of A was first 7, then 6, then 5. We keep on reducing the power of A. Then B power 1, we are increasing the power of B. B ka power will become 2. And you keep doing this, and you will get all these terms here. And the last term for sure is going to be B raised to 7. So the objective of this video was to teach you one method, okay, so that A plus B raised to n, and n can be any natural number, okay, you should be able to find out the expansion of this bracket. And the way to do that is a binomial expansion. Now all we have to do is we will write down the standard formula of binomial expansion, which you're supposed to remember. Let me make some space and write down a standard formula. Okay, and when you say standard formula, it will be A plus B raised to n. So this is the official formula for binomial expansion. See how this is. If you have A plus B raised to n, okay, now if you want to write binomial expansion, right now we have solved it for 7, okay, now we are doing it for n, right? A plus B raised to n will be, the first term 7C0 will become NC0, right? A raised to n, B power 0, that is the first term. I hope you followed this. This will be, first term will be NC0, A raised to n, the first term raised to n, and the second term raised to 0. Okay. The next will be NC1. Do you see, like 7C1, we have NC1. You have to reduce the power of A. So the power of A was n. So if you reduce the power of A, it will become n minus 1. And B raised to 1. Okay. Now keep doing that. This will become NC2. And A raised to n, we have to reduce further. So it will be A raised to n minus 2. Okay. N minus 1 will become n minus 2. So you'll reduce A more. And B will increase. So B raised to 2. Okay. And you keep doing that. And the last term will be, yeah, it will be B raised to n. But can we say NCN? A raised to 0. The power of A, we keep on reducing. Finally becomes A raised to 0. and the power of b will become n. So it is b raised to n. Okay. So now this over here, this formula here is called as binomial expansion. Okay. And this formula you can use if you have a plus b. Okay, power n. If you want to find out expansion, you can always use this formula. Just remember that to apply this formula, your n has to be a natural number. So we write like this, that n belongs to a natural number. It has to be a full number. It has to be a positive number. Okay, that's natural number is, right? So n can be anywhere between 1, 2, 3, 4, 5, 6 up to any big number we can deal with. It cannot be fraction though. Okay, so this is the expansion. And now basically with this method, it is capable of finding the expansion of anything. So if you want to find out a plus b raised to 15, okay, no problem. Okay, you can use this formula. How will this be? Be 15c0. Okay, n is 15 right now. A raised to 15, b raised to 0. Next will be 15c1, a raised to 14, b raised to 1. I hope you got what I'm trying to tell you. So this way you can find out expansion of any bracket power. Okay, and this is called as binomial expansion.